Alright everybody, this is 9.5, testing the independent sample. So we're going to have two groups, but this time they're independent. Now this is kind of like 8.5 where we went through and had the difference of the mean confidence intervals. It's kind of the exact same thing. We have two means, and we're going to have a z-score where we know the population standard deviation. We're going to have a t-score where we don't know the population standard deviation, and then we're going to do a proportion problem. I'm going to try to do that as quick as I can, doing one example of all three. So just a little background information quickly. Independent sampling distributions, there's no relationship at all of any of the values. Some examples would be incomes of individuals from two separate groups. Okay, if I have lecture class, or if you think about our stats classes, it could be, period 2 is different from period 4, and I could give you all different midterms, and then we could test for the difference of mean scores of each. So that's kind of the difference that I could do, or a reason that we could use these. Now, this is an important section, as this is what you will use a lot in your final project. Okay, so if I know my population standard deviation, you need to come, and I want you to find your formula sheet and find the z-score one with difference of means where you know 1 and 2. Okay, so kind of going through this, the mean, we're going to subtract the 2. Standard deviation, we actually kind of pool them together, and you're going to see we've done this before. Sigma of the first one, you square it. Sigma of the second one, you square it, divided by n of each, and you add them together, take the square root, and so on. That should be in your formula on the bottom. Okay? Once again, this has been kind of talked about before. The only way you can do this at any time is if I say it's normally distributed, or as long as there's 30 or more in each sample. The central limit theorem says that we can approximate it as normal. So you kind of need to keep that in question. It's just a side note. So to test, now in 9.4 we said the mean difference was equal to 0. What's different about this one is we're going to assume these things are independent. Alright? So we're going to assume that these independent events are equal, or if you would subtract the 2, it'd be equal to 0. You can list it either way. I like thinking about it as my null hypothesis every single time is that the two groups averages, the means are equal, and I want to prove that they're different. Okay? So you might do a left-tailed test where the mu1's less than, right-tailed test where the first group is greater than, or if I just want to see some sort of change, it would be just not equal to, and we'd have to look at both tails. Alright? So here's an example of the z-score one. I know the population standard deviation. So if I'm a college professor at the 5% level and I want to know if there's a difference in the final exams between two groups. One group has calculus in the traditional classroom and the other one is taught online. And I want to see, is there a difference? Alright, so you are going to have to either in the problem take out this information just from the paragraph, or it might be given to you in this format right in the table. So the x bar, the mean of my sample, first sample, okay, is 88. X bar of group 2 is 85, because you need to deem what's group 1 and what is group 2. Okay, and then standard deviation, sigma 1. And this is sigma 2, 3.3 and 4.1. And then what's N1 and what's N2? 31 in group 1, 30 in group 2. And what you want to do then is try and figure out your z-score. Okay? So here you need to, I want you to look at your formula sheet and find that. Alright? So we're going to end up having x bar 1 minus x bar 2. Notice these numbers are sitting right here. Square root of the standard deviations, you just got to plug them in. The N1 and the N2, just got to plug them in. Hopefully by doing 8.5, this is not as stressful. Okay? Now before we kind of get into actually doing it, you must set up your test. All of this is the same. What's your null hypothesis? The null hypothesis will always be the first group equals the second group. That's not going to change. Okay? What's the alternate hypothesis? What do they think? Okay? It doesn't specify. It doesn't say anything. It doesn't give any hints, which if it doesn't give any hints, you have to assume that we're just going to look and see if it's different from. If I would give a hint, then I would do the less than or greater than. compute the sample test statistic. All that means is you take your two means and you subtract them. So in this case, 88 minus 85 is 3. That's just the number that's going to go into the top of your z-score formula. Okay? And now let's compute this. I'm just going to move it so you can write it in. The difference of your sample means is 3. Why is this 0? Because we are assuming that these means, the mu's, are equal. So if you have the same amount from each of them and you subtract them, it's going to be 0. Every single time, that's what we're assuming. So every single time, notice that's your null hypothesis, that number comes into the right side of that top for your z-score. That's just no different than anything else. Alright? And then notice the 3.3 squared's in there, the 31's on the bottom. That goes right back to this table. All of this information is getting put in to your radical. So hopefully all of you can go through and be able to find that. Once you do this in your calculator, remember you got to do 3 divided by, I would do this big obnoxious radical all by itself first, and then go 3 divided by your answer. You should get 3.14 as a z-score. Okay? So with the z-score, you now have to go to your z-table or the pink sheet and get an answer. So we need to find the p-value. Now what kind of test are we doing? That's the question. So if I think about this, I have a z-score that's way out here, 3.14. Alright? And if you go into your table and you actually look at 3.14, I think you get 0.9992 as your answer. 0.9992 is the number from this line all the way this way. But do I want to go all the way to the left? We're testing the tails, remember. The extreme values. I want, and in this case, since I said it was not equal to, the left tail and the right tail. Well, I know the right tail simply by going 1 minus 0.9992, which is 0.0008. That's how I got this number down here. Now, why did I multiply it by 2? Because it's a two-tailed test, and we have to check this tail as well, which is just symmetrical. So it's also 0.0008. And then if you multiply it by 2, you get a p-value of 0.0016. So I'm going to go to the next slide. That's my p-value, 0.0016. So we would reject as long as the p-value is less than a, correct? So yes, it is less than 16 is less than 0.05, which I have that written right here. Since it's less than it, we reject the null hypothesis for that significance level. Alright? I would still reject it, so I'm not even going to go there. So we reject the null hypothesis, and what's going to be my statement? Okay? We conclude the exam results for distance learning classes are significantly different from the traditional group at the 5% level. And you can, I don't care how you tell me, or we've gotten in the habit of saying at the 5% level. You could say that first. The 5% level, we conclude that the classes are significantly different. Okay? Notice I did not say anything about which one is better, which one is higher, because that's not what we were looking for. In this case, we were just looking when it's not equal to. Okay? We're just looking to see if it's different. It is significantly different, and that's all I need to say about my test. I do not need to go jump to any other conclusions. Okay? That was for when the sigmas were known. What about if they're not known? Hopefully by now you're like, ooh, I need to use a t-score. Okay, I'm going to be given a sample standard deviation. That's literally the only difference. We're going to use student's t-distribution. Okay? And we're going to kind of keep going. Remember, this is the one that we'll use the most. I'm not even going to go into a lot of background. I'm going right into an example. Okay? So it says, suppose an experiment to measure the time and minutes for a headache medicine to enter the bloodstream after you take the tablet. So they did an experiment. Brand A gave you this x bar, this standard deviation, and this n. Okay? Brand B gave you this mean, this standard deviation, and this n. It will be listed out like that for you, or you might have to take it out of a paragraph again. I just listed it out nicely for time purposes. So now they say that brand B, the second group, claims to be faster. Is this claim justified at the 1% level of significance? So what do you need to do? Here's what you have to do, and no matter what. Alpha, list it. Okay? You have to set up your test. Now it's two groups. Null hypothesis is that they are equal. The alternate hypothesis, now it is 1 versus 2. So I'm going to say brand A is 1. Okay? Brand B is 2. Think about this logically. If the mean is bigger, which one is that? Now they claim that B is faster, but what's that actually talking about? What's our measurement? It's time. Okay? And if B is faster, that means the time is less. So what I'm going to test for, what they think, is that the second group is less than, or the first group is greater than the second group. The time is longer. So you still got to do this using logic. Alright? So that's what I'm testing. This is a right-tailed test. Greater than. So now how am I going to go about doing this? I have my test set up. To actually conclude the test, I need a p-value. To get a p-value, I'm going to use a t-score because I know the standard deviation of the samples only. So if you go to your formula sheet and you look at the t-scores, okay, all it says is x bar 1 minus x bar 2 over the square root of that obnoxious standard deviation 1 over n1 standard deviation 2 squared over n2. We need to dump all the information that we know in. So x bar 1 minus x bar 2. Our test statistics are 20.1 minus 11.2 over the square root of s of 1 is 8.7 squared over n of 1 is 12 plus 7.5 squared over 8. So if you could dump all of that in and calculate that out, I'm going to tell you right now what it is. I did it before. I actually started this. I don't want to waste any more time that I already have. Your t-score is 2.437. Alright? So I would practice making sure that you know how to do that. Now, what do I do to get a p-value? This is where you go to your blue table now because it's a t-score. What degrees of freedom do we need to do? No different than in section or chapter 8 when there's two groups. It's the smaller of the two. So the smallest n is 8. The degrees of freedom, the smallest degrees of freedom is 7. So if I go to degrees of freedom 7, I need to figure out where 2.437 falls between. So 2.437 falls between what two numbers on the 7? I'm looking at the wrong row. So 2.365 and 2.998. So 2.365 and 2.998. If you have your t-table, I would look, do you agree that that number falls between those at degrees of freedom 7? If so, we now can go up and look at what our p-value is going to be. Now, is this a one-tailed test or a two-tailed test? We said that it is strictly greater than. So if I kind of want to draw this out, some of you are visual learners, my t-score, 2.437, I want a right-tailed test. I only want greater than. It's a one-tailed test. So if I take those two columns all the way to the top to the one-tailed test, my p-value is going to be 0.01 to 0.025. So those are the two numbers, the two columns on the one-tailed test that are on the very top. Okay, given that my number falls between these two. So that's where I went up and got those two. So now I'll, just like every other time, I compare my p-value to my alpha. So now I know that it's between these two. Comparing it to 0.05, is the p-value smaller? No matter what the p-value is, since it's in this interval, it will always be smaller than 0.05. So if that's the case, I have to reject the null hypothesis. It's significant. It's smaller. It's in the tail. It's crazy out there. Alright? So how do I then finish my problem? At the 5% level, what can I state? There is evidence because I rejected it. And what does this evidence tell me? That the mean time for brand B, and what is brand B doing? Enter the blood is less than brand A. Alright? Okay, so I reject the null, and what does that say? I have to go back up. So either you can do one of two things. I said brand B, or the second group, is less time than the first group. You could say that it takes brand A more time than the second group. I don't care how you tell me it, as long as it's accurate in the test. Alright, so that's two examples for the t-score and a z-score. The last one is the proportion. So hopefully by now we're like, okay, I know what to do. I'm looking for probabilities, things like that. This is the very last thing in Chapter 9 formula sheet. Alright, I want you to go to your formula sheet and find these right here. This is important. Now this is a little bit different, it's a little bit longer. I'm going to try to go through this as quick as possible. So you're going to read your problem. County clerk wishes to improve voter registration. One method is to send reminders to people that are eligible to vote to actually vote. 1,100 voters were randomly divided into two groups, so they randomly divide these two. So 500 of the potential voters were not sent reminders, and they told you that 248 registered. 600 were in the other group and were actually sent the reminders, and this is how many actually registered. And it says, does the data support the claim the proportion, there's your hint, of voters who registered was greater in the group that received reminders than the group that did not? So they think, they just said that the group that sent reminders, they think proportionally they will vote more. Now how do I go about doing this? Well, you need to do a couple things. You need your point estimate, your p-hat, if you want to think about it that way, of each group. And I like doing that first before I even do anything. Okay, so the first group, p-hat, what's the first group? 248 out of the 500. And that's equal to 0.496. p-hat 2, okay, that's the 332 over how many? 600. And that's equal to 0.553. You need to have your p-hat 1 and p-hat 2 before you really can do anything. Alright? Once you have that, before you actually move on, you should check your n times p, your n times q of both groups, no different than anything else because it's a proportion. Now I'm not going to do this on paper because let's be honest, 50% of 500 is way above 5, and 51% or whatever of 500, all of these are way above 5, but you still should check that. Alright? Then you need to set up your test. Now they're testing at what level? The 1% level. What are they testing? Now notice, remember in the other ones, your null hypothesis was mu1 equals mu2. Same thing here. We're going to assume that these proportions are equal, and we want to prove it wrong. Alright? How do I want to prove it wrong? They told us that they think the people that get reminders will vote more. Now, group 1 does not get reminders, so I think they're less than the group 2. This is a left-tailed test. Alright? And now how do I test something? I need to find the z-score. Now here's what's tricky. Look in here. There's what we have, p-bar. What is p-bar? You actually need to calculate this before you can find your z-score. Okay, you have to do an aside, what we call in math. So p-bar is just that they pool everything together. So R1 plus R2 is what they give you in the problem, 248 plus 332. Over N1 plus N2 is your 1100, it's the 500 plus the 600. They think this is a little more accurate for the proportionality for the standard deviation part when they can get a little bit more information. That's why they do it. So if you calculate this out and divide It's 0.527. So then Q bar would be 0.473. Just the 1 minus that. So now you need to calculate your z-score. This should now be no different than anything else, so except we're using proportions and percentages instead. So p hat 1 minus p hat 2. 0.496 minus 0.553. Divided by the square root. Now what's p bar? We just calculated p bar. So it's 0.527 times the 0.473, and you divide it by n1. And then if you look real closely, it's still p bar times q bar. It's both of them in here. So it's the exact same top. Except you divide by 600. So that's really the only thing that's different. And you just calculate all of this out. And if you guys practice this, I would highly recommend practicing that. You get a z-score of negative 1.89. Okay? I'm going to have to get a new page, so I'm going to insert a page after this. So you guys are going to have to refer to all of that information that I just got done doing. So now I know that I have a z-score of negative 1.89, and I know that I'm testing my alternate hypothesis is that P1 is less than P2. If that's the case, that's a left-tailed test. My z-score is negative 1.89, and I'm looking for a left-tailed test. This is sweet because I'm using a z-score, and my z-score table happens to give me all of that information. So when I go in and find that, this number is 0.0294. Okay? So I know that from the table. So if I compare 0.0294 to my alpha, which is 0.01, is my p-value less? It is not. Since it's not less, it's not far enough out to be significant, we fail to reject the null hypothesis. And if we fail to reject the null hypothesis, what do I say? At the 1% level, the data, what does the data do? Does not support the claim. And what did we claim? That reminders mailed increases. Does not support the claim that if you send reminders in the mail, it'll increase the proportion of registered voters. And what does that mean in real life? If you're going to vote, you're going to vote. You don't need to be reminded to vote. Okay? You're going to vote. You got to know when that's going to happen. So that's basically what's that saying. We failed to say that there was a significant difference in the groups. So at the 1% level, you can just say the data does not support the claim that these reminders will increase the proportion of registered voters. So that is the very last one. I know that's a lot of information. We're going to spend an entire day or two working through these. Here is your assignment, and you guys have a super day.